I'm here today with Mr. Alexander Bychkov, who represents Rosatom in Vienna. And for much of his career, he was a researcher and the head of the laboratory at the Research Institute of Atomic Reactors was that in Moscow? Or Dimitrov. And for several years, he was heading nuclear energy at the International Atomic Energy Agency. So you have deep technical expertise, but also a lot of experience in these international projects and studies that the International Atomic Energy Agency has done on the nuclear fuel cycle and plutonium. So you're officially, I guess, a representative of Russia. Yes. What is the Russian, or Russia's outlook for nuclear energy and plutonium in particular?
Oh, first of all, Russia is one of country that continue development of nuclear power. And we have now maybe position number one in nuclear market, not only
in exporting, absolutely.
Yes, and not only in nuclear power, in fuel cycle too, and in area of new business, research center for nuclear science and technology. And of course, we keep initial conception of closed fuel cycle. Of course, our technologies for fast reactor implementation had some maybe historical break in the 90s, but some years ago we commissioned a new fast reactor BEN 800s, and this reactor today for Russian nuclear industry is key element for closed fuel cycle.
So Russia is the only country right now that is operating this fast reactor at a commercial level. Many other countries have tried to operate fast reactors, but they weren't. They didn't operate very well. They didn't operate enough to produce electricity on a consistent, sustainable level. What's different about Russia's BN 800?
Oh, first of all, we try to keep long strategical lines. Mm-hmm. Of course, sometimes it is not easy to solve today's commercial problems and some tasks. But from point of view of long strategy, of long-term tendency, fast reactor is very important. First of all, we avoid accumulation of spent fuel. We can use plutonium and other minor actinides in closed fuel cycle of fast reactors. And if in future we are going to multiply a number of these reactors, construct new reactors, and we expect that economical indexes of these reactors will be much better than today. And so it will be comparable with light water reactor technology. And of course, the key element of fast reactor economic, it's free initial materials, plutonium. Now plutonium
not exactly
separated.
Free, right? I mean, you had to make the plutonium in these light water reactors. Just because I think our audience may not have PhDs in nuclear physics or engineering. Fast reactors, it's a different design of a reactor. It's been around for 70 years, 60 years. Just explain very simply how it differs from the thermal reactors or what we call light water reactors that most countries in the world use.
Of course, now the fast reactor is not subject for export due to, first of all, fast reactor should use high enriched materials. For example, if we speak about MOX fuel, it's 20% of plutonium in the mix with uranium. But if consider technology of fast reactor includes specific aspect, for example, operation with liquid sodium, or in future liquid lead or lead bismuth alloy. Of course, it is not easy technology for commercial application just today.
Right, but the idea, the concept is that you used fast neutrons, right? So they're not slowed down by...
But fast neutrons, first of all, can, if you change configuration of reactor, you can use this reactor as producer of plutonium, converter of plutonium, or burner of plutonium.
Right.
And of course
very
now,
flexible.
yes, and now we try to keep tendency to use our reactor as burner of plutonium.
Right.
Due to Russia has, stockpile of separated plutonium, and maybe in future we will dispose by fast reactors some excess of military plutonium.
Right, so you have no stockpile of civilian plutonium, but you have a lot of military plutonium.
Oh,
correct?
Yes,
Yeah.
similar as in US.
Right, yes, well...
In military.
Exactly, right. So you're looking forward to the future of where fast reactors may substitute or really be the primary workhorse for nuclear energy.
Well, in near term, we consider fast reactors mainly for our country. But the fast reactors
not for export
could be included in international closed fuel cycle. We can take back spent fuel from our partners, for example, from Iran, Bangladesh, other countries. We can reprocess these materials, and we can use separated plutonium and maybe minor actinides in fast reactors, in our fast reactors. So in that case, we can avoid accumulation of spent fuel in some countries where it is not suitable.
This is one of the reasons why the nuclear security summits focused on highly enriched uranium, because they made a judgment that, a non-state actor, a terrorist group, if they got some highly enriched uranium, it's pretty easy to hide. I mean, it's difficult to detect if someone were trying to hide it.
I think it's very correct idea.
Yeah.
Yes, and I was involved in the process of take back of Russian Soviet Union produced fuel to Russia, and now I think we have a much better situation than 20 or 25 years ago. A few countries now have high enriched uranium. As usual, it is not weapon condition. As usual, it's
right.
for research reactors. And I think our country has stable, from one hand, support of this tendency, but from other hand, we think that for some scientific reasons, for production of some isotopes, if it's necessary, it's possible to use high enriched uranium, or relatively high enriched uranium, maybe 45%, 36%, not 90%.
Right, so for those who may not know, weapons grade is generally considered 90% or above, and reactor grade is somewhere between 3.5% and 6% of the isotope U-235. So what you're talking about is kind of a high, a mid-range of enrichment.
But for some research reactors, the content of 235 plutonium should be relatively high. It's now standard 19.7% of enrichment, and for test reactors, of course. For test reactors, for reactors which are involved in production of medical isotope, industrial isotopes.
We had 4 nuclear security summits, and towards the end of that, and Russia, can't remember if you participated in the first one, but gradually dropped out of the process. the majority agree that we should phase out highly enriched uranium in the civilian sector because of these risks, that the material could be diverted or stolen. What exactly is Russia? I mean, Russia is still producing highly enriched uranium, correct?
It is also not very high level. We have a number of reactors which are working with high enriched uranium. Mm-hmm. For example, sometimes it's impossible to convert high flux reactors to low enriched uranium. The similar situation in Oak Ridge National Laboratory. And
it's not possible, or it's not cost effective?
It is not possible.
Not possible. Not physically possible, yes, because you need the high neutron flux.
You will lose the flux of neutrons. This is a key important point. It's
right.
Reactor in my Dimitrovgrad laboratory, SM, and high flux in Oak Ridge. Both reactors cannot be converted to low enriched uranium. And from other hand, some reactors in Europe, in Munich, future reactor in France will work with enriched uranium, but not in very high level, but more than 20%. More than 20%. It's, we think that it's possible, and if the country and facility has modern level of nuclear security and physical protection, it's possible.
What are the technical alternatives for, are there other ways to?
For some isotopes, we have no technical alternatives. For example, very important isotope, californium-252, it's impossible to produce by accelerator or...
And what is that used for?
Well, first of all, it's neutron source for some medical treatment.
Cancer therapies?
Yes, and it is a neutron initiator for reactors, for startup of reactors. And it's very important isotope for some space studies, and unfortunately it's impossible to produce without high enriched uranium.
Okay. Any other issues you'd like to address?
So I worked with plutonium many years, and I keep maybe initial Soviet Union philosophy, and this philosophy till now, I think, main line for Russian specialists who work with plutonium. Plutonium, really today, it is maybe more valuable resource of energy produced by human mind and human hand. And so we should use this material in future. Of course, we should keep high level of nuclear security. We should keep current level of export control of any technology related with plutonium. But plutonium is very valuable and important resource of future sustainable development of our world.
Yeah. Thank you for sharing your views today.
Thank you. Sure.
All right.